So when we would simplify our exponent rules, looking at these different problems, trying to find out where there'd be more of the variable, and then also can we simplify the numbers that go with that. So like for instance, I think about like number 1 as 2 separate parts of this problem. I'm thinking about it as 16 over 28, and then also p to the second over p. They're kind of 2 separate things. So if it helps to kind of break it down that way, I don't know. But like both 16 and 28 can both be divided by 4. They're both divisible by 4, so we would do that, and we'd end up with 4 over 7. And then I look and see, well, there's more p's on top. There's 2 on the top, 1 on the bottom. That means there'll be 1 left on top. And again, we did this a few chapters ago with our exponent rules. That will definitely be on our exam. So it's probably good for us to review this and think about this a little bit. And then we'll bring in some factoring as well today. So the same thing with the next one, the 15 over 30. I'm going to think about that as just a normal fraction. 15 out of 30. That means we have half of it. We divide them both by 15. 15 is half of 30. And we look and see where are there more ends. There's 1 on top and 3 on the bottom, so there's 2 more on the bottom. We do need to leave the 1 as a placeholder on the top because this is still a fraction. This is not the same thing as 2n to the second, like not in a fraction. We need to make sure it's like 1/2 there. And then our last one, hopefully you guys notice the 16 should just cancel, or 1 over 1 if you want to write it that way. And there's more r's on the bottom. There's 1 more. So again, we have to put like a 1 as a placeholder to show that the r ends up on the bottom. So this is all from our exponent chapter we did a few chapters ago. But at the same time, knowing that, bless you, this is something that I know was not everybody's favorite. So it definitely was a tougher topic, and if they struggled with it a little bit, hopefully this will maybe help us remember how to do that and kind of get us going and to understand a little bit better. So we're going to simplify something called rational expressions today. Now, rational expressions, so just to kind of define that. The word rational has the word ratio in it. And so when you see the word rational, it means it has a fraction in the problem. And so some of you guys are like, oh no, fractions, that's going to be a bad thing. But at the same time, we're not, it's kind of hopefully going to help you guys maybe be a little more comfortable with fractions and working with them. But at the same time, it is something that if we take it step by step, I think it's doable for everybody. But anytime you see the word rational, they're talking about fractions. And that means that we have variables in the top and the bottom. So we get some pretty complex fractions here. And expressions just means there's like no equal sign. So we're not actually solving these equations, we're just working with them the way they are. All right, so let me... Okay. So to simplify rational expressions, we may need to factor first. And so some of you guys factoring obviously maybe wasn't as good of a topic for you, but hopefully us reviewing it today will be helpful. The other part I want to mention about this, should be another little star here. part of this is we're going to do a lot of canceling in this section, but we can only cancel with multiplication and division. And I'll show you what I mean by that, where I say can cancel and can't cancel. So this is an example of something I'd be able to cancel. So you guys are taking notes with us, please. So what I would be able to cancel here is I see a 5 on the top and the bottom. So I would be able to cancel that. So I'd be left with x minus 2 over x plus 3. Now you might say, well, why can't you just cancel that x now? That's an example of something we cannot cancel. So I can't go any further with that. So I can't cancel any more after this point. And the reason for that kind of comes from if I actually tried a number in there. So let's choose the number 5 for x. So let's say 5 was x, and we're saying 5 minus 2 over 5 plus 3. That would be 3 over 8. What we're saying is that, can we just cancel those 5's out and just have this be equal to negative 2/3? We're saying that that's not possible. So that's kind of the thought behind this, is I can't cancel because it says I can only cancel with multiplication and division, and these are addition and subtraction. Whereas over here, those 5's are being multiplied there. Let me show you something else that we can cancel. So another one we can cancel is something that looks like this. So if you see something like this, x times x plus 4 over 5 times x plus 4, since the x plus 4 is being multiplied, the whole thing is being multiplied to this x, I can cancel that. So that's going to equal x over 5. So it's okay in that case because they're identical to each other and they're like in parentheses and they're being multiplied to those other values. Guys, I really don't feel like you're focusing, so somehow make it look like you are. Another example of something we can't cancel is if I have 5 over 5x plus 12. So I can't just say, since there's a 5 in the top and the bottom, I can cancel those. I'm not able to because the 5x is being added to the 12 here, so we cannot cancel those 5's. And this will come up, and this is a really common mistake that students just see, oh, x and x, 5 and 5, I'm just going to cancel that. I can only do it, again, if they're just being multiplied in front of something or being multiplied kind of on the end there. So we'll kind of hopefully show you guys examples of where you can and where you can't, and hopefully it'll make a little bit more sense as we go through this. So again, so like looking at what we're going to do with this is in letter A here. If you notice right now, the 45 is not being multiplied to anything. So I can't just choose to start simplifying. So I'm going to have to factor first. Now, to remind you guys of factoring, we made a whole chart on factoring. I would suggest always starting with the GCF first. If a GCF doesn't work, then we can talk about other types of factoring. So looking at this first problem here, the 45 obviously can't be factored. But 10a and 10, we can factor out a 10. There's a common factor of 10. So I'm going to divide that out of each of those. So I'm going to take it out of this and this. So I'm going to have a minus 1. Now this problem is not done. We really haven't done anything. All we've done is factored it. So I'm going to rewrite it down here. So what we can do now is 45 and 10 now are kind of like on their own, kind of like in the warm-up question where I said you can kind of think of those as two separate parts. So 45 and 10 we can simplify. I'm going to divide them each by 5. So 45 over 5, or 45 divided by 5 is 9. 10 divided by 5 is 2. And so this would be our simplified version of this. And we're going to do a lot of the same type of questions here, and so hopefully this will make sense. If it doesn't, hopefully us working on it for a few days it will. So again, we're going to try the GCF first. So if you look at this one here, again, I would always suggest trying to factor before I just try to cancel. Like you see 2 and 2 and you might think, oh, I can cancel those out. Try to factor first, because we actually can't cancel those. So the 2r minus 4, I can take out a 2. So I'm looking at both the top and bottom kind of separately right now. We're going to divide out a 2. So we'll be left with r minus 2. So our GCF factoring from last chapter is kind of where this is kind of important, and we're going to use that. Now the bottom is just r minus 2. Now since they're on both the top and the bottom and they're identical, we can cancel them. So this just ends up being 2 over 1 or just 2. Okay. And like I said, this is something that is not something I get to every year with my classes. It's definitely a little bit tougher concept, so do your best to try to, again, if you can get the factoring out of it, that's awesome. If you can get the canceling out of it, that's awesome. If we can put them together, even better. But we'll kind of talk through this and hopefully make sense. All right. So again, we want to simplify. And if you notice at this point, we really haven't grabbed our calculators much at all. Your calculator is not able to simplify this for you. So please don't try to put it in. Your calculator will just do some crazy things, and that won't be helpful in this case. So the top right now, there's nothing that can factor out. But on the bottom, we can take out what at the bottom? What are we going to take out? Yep. 3, there's actually something else too. Do you see it? 3x. Yeah, we can actually take out a 3x. So we want to take out as much as we possibly can, that greatest common factor. So we had a common factor of 3, but the greatest common factor would be 3x. And we want to make sure we pull that completely out. So we're going to take it out of, and again, if you like showing that, you can. I don't know if that gets more confusing. But this ends up just being an x, and then this ends up being minus 4. And a lot of times on these are set up really well this way, that they're set up so that things will cancel. So I see this x plus minus 4 on the top and the bottom. So again, all I do is simplify that, and it just ends up being a 1. There's nothing left over there, so I put a 1 as a placeholder, and just 1 over 3x. But again, this is kind of why we need factoring. This is one of the reasons we use it and are able to work with it. All right, so this next one's a little bit different because the bottom, hopefully you notice, well, something's got to happen with the bottom. But the bottom, there is no GCF. So this is our different type of factoring. So there's no GCF here. No common factor. So what we have to do is think about the other types of factoring we have. So the other type of factoring, probably the one I think you guys probably like the most, is anytime the variable is just first and being squared, this is where we go to like that reverse FOIL, the 2 sets of parentheses. And again, this was on our last test, so hopefully jogging your memory a little bit. So I know it's going to be V and B. I want to multiply to 25, but add to negative 10. So multiply to 25, but add to negative 10. Anyone think they got it? Yeah, what do you got? Minus 5, minus 5, and minus 5. So two negative 5s. And now again, when I go to do this, I see that the x, or the v minus 5 and the v minus 5 would cancel on the top and the bottom. And I can only cancel one of them though. So I'm left with 1 over v minus 5. If you want to keep it in parentheses, you can. You don't have to. But we just get to cancel that out and simplify it a little bit. So the different type of factoring, if you're not feeling comfortable with it, feel free to grab, we had made a chart with our factoring. Just a reminder, those of you guys who are still taking your test today, you can use your charts. So you can use your factoring chart and your solving quadratics chart. And actually Dean had also asked about other notes, like the review notes. I said, sure, like let's just throw those into it. And it was perfectly fine. So those of you guys going to take the test today, just so you guys know, basically I'm going to tell them you guys can use your notes. So you're welcome to use any of those. The charts obviously I think are the most helpful. All right, so now letter C is one where even my Algebra 2 students, even my trig students want to do this. They see those 27s, they just want to cancel. We can't do that yet though. We can't just cancel those out. So we do not want to, so this is what not to do. So we can't just cancel those 27s. The reason for that is because 27x is being added to 18. So what we need to do instead is we need to factor. So I'm going to try to factor something out of 27 and 18. So we want to find a common factor. So 27 and 18, yeah.
3.
There's a bigger number. Yeah.
9.
9, yeah. We're going to take out a 9. So 3 would have worked, but then hopefully you would have noticed, oh wait, they still have a common factor, but it's not the again, looking for that greatest common factor. So we take out that 9. 9 divides into both of them. So we get 3x plus 2. And then 27 over 9, now we can look at that in terms of canceling. 27 divided by 9 would just be 3 over 1. So the 3 would be on the top, or I can divide these both by 9, and then we just have a 3x plus 2 on the bottom. Again, we would stop here, because we can't factor 3x plus 2 anymore, and I can't just cancel those 3's. Again, because the 3x is being added to 2. Letter D is another great example of things that people want to do, but we should not do. So, see those b squares, we just want to cancel them. But again, they're being added to the next thing or subtracted. The next thing is being subtracted for them. So instead, immediately, if you think I want to cancel right away, take a step back and say, can I factor first? Most of the time, you're not able to just cancel right away. So let's try to factor first. Now these both start with b squared, and they actually both don't have a GCF. Now this first one has 3 terms, so I know it's going to be b and b. I want to multiply to negative 28, but add to 3. So I'm multiplying to negative 28, but adding to positive 3. See it? Our negative 4 and positive 7 will be our factors there. Now the bottom is a little bit different type of factoring, but I think the bottom, once you remember this type of factoring, I think it's one of the easier ways. There's no GCF, so I know it's going to be b and b. What are we trying to multiply to get in this one? What are we trying to multiply to get? Yeah, the negative 49. And what are we adding to get though here? Yeah, Not 1, 0, yeah. We want to add to 0 because we want that middle term to cancel out. So multiplying to negative 45, this is one that's called difference of squares. They are perfect squares. Yep.
Plus 7 minus 7.
Nice work. Do you have a helper over there? No, I didn't think so. Okay, good job. So the b plus 7 is going to cancel. And we're going to be left with b minus 4 over b minus 7. And again, we just leave it that way. The b's don't cancel because they're being, like, different things are being subtracted from them. So we just leave it that way. All right, we're looking at the last 2 questions, and you guys have time to work on homework. Again, the homework is really just trying to get these factored and see what you can cancel. Now, on the homework, it says to just simplify. That doesn't make a lot of sense right now because that's what we're doing right now. But if you look in our book also mentions something else about like excluded values. We're not going to worry about excluded values this year. So we just want to simplify the way we're doing. So just doing what we're doing for our notes right now. Don't stress about what they talk about with the excluded values. All right. These are a little bit more complicated though. So the top up here, looking at that, again, I always want to look for a GCF first. And the top does have a GCF. What comes out of the top? Comes out of the top. Yep. 6b to the second. Yep. So we're going to take a 6b to the second out of the top. It's a common factor. So I'm going to take that out and be left with v plus 7. Now I'm going to tell you guys the bottom also has a GCF. Not a very interesting one, but it has one. If you guys notice, all the bottom numbers can be divided by 2. So I'm going to start there. If you wanted to right now, you could simplify this 6 over 2 because those are being multiplied to the rest of this. I'm probably going to wait to do that. So I took that 2 out of the bottom. Now what I see is left in the parentheses is kind of yelling at me that it wants to still be factored. So I'm still going to factor the bottom a little bit more. Because I see the bottom now, we have that v squared. So we're going to do v and v. We want to multiply to 42, but add to 13. Multiply to 42, add to 13. And I guess I'll tell you guys a little trick as well. The top is kind of giving us a little bit of a hint. We want things to cancel, and these problems are set up so something's going to cancel. So I'm hoping I end up with a v plus 7. Does 7 times something equal 42? Yeah, 7 times 6. So the top is kind of giving you like a good clue to say like, well, these have to end up matching. They don't have to, but it's probably likely if it's in this section. So 7 and 6 are 2 factors because that will give us 13. And so then we'll get to cancel those v plus 7s. Now I also want you guys to notice we can also cancel this 6 over 2. Those can be both divided by 2. So it's going to be 3v to the second on top. 6 divided by 2. This 2 is going to cancel. So it's going to be divided by 2. And then this will have v plus 6 on the bottom. So kind of a lot going on there. So if you're not understanding what I just did here, I simplified that. So 6 over 2 becomes 3v to the second over 1, or just 3v to the second. Okay. So again, finishing up with our last one here, has GCF factoring and also the reverse FOIL. So this top part here, I can take out an x. Hi, thank you. The bottom part, I can take out a 2. who came for the very last example. Everything should be crystal clear in a second here. Sorry. All right. Now again, these two, hopefully you're starting to notice, you're like, oh wait, that's that type of factoring we know how to do. Again, we're going to do the x and x. On the bottom, same thing, x and x. And again, you can maybe go with whatever one looks easier to work with. Do I want to multiply to get 42 and add to -1? Do I want to multiply to 21, add to -10? Does someone have one of those they think they know? What do you guys think? Yeah.
Well, the 42 one, you do 6 and 7.
Yep, so +6 and -7 will give us that -1. And then once we use that one, then I'm thinking either 6 or 7 will work with the bottom one. And so I know 6 doesn't go into 21, so we try 7. 7 times 3 would multiply to be 21, and if they're both negative, we'll get that -10. So -7 minus 3. The order you put these in doesn't matter, because we still just have to cancel them. So the x minus 7s will cancel. And this is one where it kind of gets left with a lot going on, and that's okay. So we have this on top, we have this on the bottom, but again, since the x's are being subtracted or added by something different, we can't cancel those. The 6 and 3 can't be canceled because they're connected to those x's. So this is just how we stop here. So this one kind of ends up not being all that simplified. If you're like, oh, I tried to FOIL that in and put it this way, that's fine as well. It's the same thing. It still can't be canceled though. Okay? So our homework is listed there for you guys. Again, what you're doing there for your homework is exactly what we did today. So don't read into the directions too much. We're just doing the same thing. Work through it. Some of them I think are like our warm-up questions.